Hello 12 CBSE students, welcome back to our online classes. We are in a process of completing our last chapter in first volume, application of derivatives, and already we have seen what is rate of change, correct? What is tangents and normals, and what are the approximations. So nearly we have completed 3 exercises in that chapter, okay? And I hope that you people also are thorough with all those three exercises, right? Today we are going to see the most important topic in your mathematics, Kanna. Okay, so hereafter whatever you are going to study will be reflected in your future. It means when you are going to college, then definitely you will study all those things again. Okay, so hereafter I am saying it means the chapter what all is there in second volume is all going to come in your college. Okay, so very important, as well as these concepts and all will be there in each and everything, Kanna. Okay, even when you study next level, that is in your college, if you are going to take engineering, okay, so anything related with electronics, okay, electrical science, so all those things will be having this increasing and decreasing function and maximum minimum. Okay, so it is very important topic. You should know what is what. Okay, once you understand the basic, any sum whatever they are giving you can do. Okay, so the basic understanding of a concept is very important. So please listen carefully, right? So today we are going to see about increasing and decreasing function, right? On hearing this word, what do you think, Kanna? Increasing, something is going up. Decreasing, something is coming down. That is the logic. Okay, so don't think that you increasing, decreasing, merely 30 sums are there, I cannot do. If you think like that, definitely it will become difficult. Okay, so you shouldn't think like that. What you have to do, what is an increasing function? A function which is going up. What is a decreasing function? A function which is coming down. That is called as a decreasing function. Another one is called as an increasing function. Okay, in this increasing and decreasing, we have, it is further divided into two more types. One is strictly increasing and another one is normally increasing. And here also in decreasing we are dividing into two more. One is strictly decreasing and another one is normal decreasing. What is strictly increasing, sir? It is only increasing throughout. It is called as strictly increasing. What do you mean by increasing? Increasing means at some time it will become a constant. That is said to be as increasing. Similarly, in decreasing, if it decreases throughout, it is called as strictly decreasing. At some place, if it becomes a constant, it is said to be as only decreasing function. Okay, sir, can you give me an example? Yes. So I have drawn 4 diagrams here. Okay, I have drawn 4 diagrams here. I can easily say which is increasing and which is decreasing. Even though if I am not going to write this, definitely you can find which is decreasing function and which is increasing function. Very simple, right? Now check out this one, right? So this graph is increasing from bottom to top, correct? It is going up. You can ask me, sir, if it comes down, sir, this is origin, sir. This is positive x-axis, this is negative x-axis. From 0 only everything will go, correct? So this graph is going up. Am I correct? This graph is what? Going up. Okay. Now, let me consider a value x1 and x2 such that x2 is greater than x1. Positive x-axis only, learn. So x2 is greater than x1. Okay. Now what I am going to do is, from x2 I am going to draw a line to the graph. From that point I am going to draw a line to the y-axis, that will be f of x2. And similarly from x1 I am going to draw a line to the graph, perpendicular to the graph. From that point I am going to draw to the x-axis, that will be f of x1. Correct? If x2 is greater than x1, f of x2 is greater than f of x1, it means it is strictly increasing. Okay, x2 greater than x1, f of x2 is greater than f of x1. If I am going to substitute any x value in my function, okay, if that x value, the substituting x value, first substituting x value is greater than the second substituting x value, and the answer is also similar to it, then definitely I can say the function is increasing. See, x2 greater than x1, and it also gives f of x2 greater than f of x1, then it is said to be as what? Strictly increasing. Can you understand? Yes? Okay. Now, again I am taking x2 and x1, Kanna. You forget about this dotted line, right? x2 and x1. Again see, if I take x2, f of x2 is having higher value than f of x1. So again it is also an increasing function, right? But it is not strictly increasing. Why, sir? If I am not going to take x1 as this point, instead I am going to take x1 as some other point here, okay, and I am going to draw a perpendicular. Now what happens is, your x1 and x2 have become equal, correct? Because the graph having a slope 0. Slope 0 means dy by dx 0. So it means there is a parallel line to x-axis, right? So a graph is having a parallel line towards x-axis. It means it is not increasing throughout. At some point it is becoming a constant. So on those cases, this type of graphs or this type of functions are said to be as what? Increasing function. On some case, what happens? x1 and x2 will be equal. F of x1 and f of x2 will be equal. And all other cases, x2 will be greater than x1, f of x2 will be greater than f of x1, means it is said to be as what? Only increasing function, not strictly increasing. Can you understand what I am saying? Yes? Okay. So on some cases, it has x1 equal to x2, f of x1 equal to f of x2. It means it is increasing, not strictly increasing. Strictly increasing means only positive value. It will go on. Okay, it will not have any constant function in between. Okay, but here it is what? Increasing function, because both are equal at some point. Okay, now let us come to the decreasing function. Again I am drawing a graph. Now see, the graph is coming down, correct? Graph is coming down. So from 0, so the graph is coming down, right? Now I am taking x2 and this is x1, drawing a line. Now listen, your x1 function gives a higher value than x2 function, correct? Even though your x2 is greater than x1, okay, the value of x1 when it is substituted in the function is higher than the value of x2 when it is substituted in the function, correct? So x2 is greater than x1, but f of x2 is less than f of x1. It means it is strictly decreasing. x2 greater than x1, f of x2 less than f of x1, strictly decreasing. x2 greater than x1, f of x2 greater than f of x1, strictly increasing. Understand the logic? Here less than or equal, less than is there, here greater than is there. Okay, now listen about this one, decreasing function. What happens? Again I am taking x2, again I am taking x1. Now your f of x1 is greater than f of x2, correct? Yes, so it is said to be as decreasing. But at some point what happens is, if I am going to draw a dotted line x2 here, what happens is your x2 value and x1 value will become equal. So at equal condition, f of x2 will become f of x1. See? So what happens here? If x2 greater than or equal to x1, f of x2 greater than or equal to f of x1, it is only increasing. And similarly, x2 greater than or equal to x1, f of x2 is less than or equal to f of x1. It is said to be as only decreasing function. It is said to be as only what function? Decreasing function. Can you understand the logic? Yes. Strictly increasing means it will be like this, always going up. Increasing means at some point it will become a constant, like staircase. Okay. Decreasing means it will be always coming down. Strictly decreasing means it will be always coming down. Decreasing means it will be a staircase shape, right? Which is decreasing, coming down, right? So this is strictly increasing, this is increasing, this is strictly decreasing, and this is decreasing function. Can you understand? So this is how we categorize a function. That's all. Okay? Right? Can you understand the logic what I am saying? Yes? Super. Now you can ask me, sir, where does differentiation play a role here, sir? If this chapter is included in application of derivatives, correct? There is no differentiation. By only seeing the curve of an equation, how can we say, sir? Only seeing curve of an equation, we are substituting and we are getting the answer. Where is differentiation part? Now, these curves are very simple curves, easily we can find, correct? If I am going to write an equation like this, 2x power 4 minus 3x square plus 2x plus 1, then how will you draw a curve for this one? Correct? So, it is difficult to draw a curve when an equation is given like this. Okay, we cannot substitute each time when it is in trigonometric equations. So, what happens? We cannot draw each time, right? So, it will become difficult. Okay, so on those cases, we started using differentiation. On those cases, what happens? We started using differentiation, right? So I'll tell you how to use differentiation in finding increasing and decreasing function. Okay, let us move to the three trigonometric basic functions, Okay, so we have to check how it is increasing or decreasing. Okay, now please listen. I'll take for sin x. Now already we have studied in inverse trigonometry. I think you people remember it, right? So from 0 to pi by 2, the sin x value is increasing. Am I correct? From 0 to pi by 2, the sin x value is what? Increasing. So sin x value is increasing. From pi by 2 to pi, From pi by 2 to pi it is decreasing, correct? And from pi to again 3 pi by 2 it is also decreasing, am I right? From pi to 3 pi by 2 again it is coming down, it is decreasing. From 3 pi by 2 to 2 pi, what happens? It is going up, so it is increasing. This is what we wrote in your inverse trigonometry. Do you remember it? Yes? Super. So the same logic we are going to use here. Okay. So on seeing the graph, we can easily say on which quadrant it is increasing, on which values it is decreasing. Right? And similarly, can you tell me for cos x? For cos x, from 0 to pi by 2, it is decreasing, correct? Then from pi by 2 to pi by 2 to pi, it is what? Decreasing. Then from pi to 3 pi by 2, pi to 3 pi by 2, it is increasing. Super. Then from 3 pi by 2 to 2 pi, 3 pi by 2 to 2 pi, it is also increasing. Can you understand? So this is how your graph of cos x is being framed. Correct? And similarly for tan x, can you tell me from 0 to pi by 2, the curve is going up, so it is increasing. From pi by 2 to pi, the curve is again going up, so it is increasing. From pi to 3 pi by 2, again the curve is going up, so it is again increasing. Am I correct? Yes. From 3 pi by 2 to 2 pi, again going up, again increasing. So, tan x is always called as ever increasing function, correct? So, tan x is always what? Ever increasing, always increasing function. And what about cot x? Always decreasing function. Very simple. So tan x is always an increasing function means cot x is always an decreasing function. Now, I am going to ask a very important question to you here. Now, please listen. Please listen. Okay, very, very important. Please listen. Now, if I am going to say like this, from 0 to pi, is sin x increasing? I am going to ask a question to you, right? From 0 to pi, is sin x increasing? Definitely the answer is no. From 0 to pi, is sin x increasing? The answer is what? No. Why you say no, sir? From 0 to pi by 2 increasing, then you can say pi by 2 to pi decreasing. Yes, I can say like that. But in the interval 0 to pi, it is not increasing. Why? Is it decreasing, sir? No, it is not decreasing also. Then what you will say, sir? I will say that the function is neither increasing nor decreasing. Neither increasing nor decreasing. Can you understand what I am saying? If I am going to roughly ask a question like this, from 0 to pi, is the function increasing? I say no. And from 0 to pi, the function decreasing? I say no. If you ask me why, I will say it is neither increasing nor decreasing. Because if I am going to have a particular limit, in that particular limit, the function, if they are asking whether the function is increasing, it means it should only go up. It should not come down at any point. Okay, and similarly, in a particular limit, if they are asking whether the function is decreasing, it means it should come only down. Okay, it should not go up at any point. So if it is having a reverse condition, then I will say that it is neither increasing nor decreasing. Can you understand what I am saying? Now look, 0 to pi, here the function is going up and then coming down. So it has both positive. Up means let me consider it as positive, right? Down means let me consider it as negative. There is a logic behind it, I will tell you later, right? So up means positive, down means negative. So both negative and positive is there in a particular limit. Therefore, it is neither increasing nor decreasing. Can you understand what I am saying? Yes. And similarly here, from pi to 2 pi, is sin x increasing function? No. Is it decreasing function? No. What do you say? It is neither increasing nor decreasing. Why? Here we have negative value, here we have positive value. Can you understand? From 0 to 2 pi, is sin x increasing or decreasing? It is neither increasing nor decreasing. Can you understand the logic what I am saying? Which is very important, Kanna. These type of questions they might ask in 1 mark. So that is why I am explaining to you, right? Y equal to cos x. Y equal to cos x. How to explain this one? I think you can say, if I am going to say from 0 to pi, the function is decreasing. Is the statement correct? Immediately our brain will say no. I will also say no. Okay, not for no for this answer, I am saying no for you. Why, sir? From 0 to 2 pi both are decreasing. Yes, it is a decreasing function. This is negative, this is also negative, so decreasing only, so it is a decreasing function. Can you understand? It is going down only, so decreasing function. Is there any value which is coming up and going? No, so every function it goes down, so it is a decreasing function. From pi to 2 pi, the function is increasing. Am I correct? Yes, it is an increasing function. It is going up only, so it is an increasing function. If I am going to ask like this, from pi by 2 to 3 pi by 2, for cos x, what will happen? I can say it is neither increasing nor decreasing. Can you understand the logic, Kana? Here I said ever increasing, I cannot say neither decreasing nor increasing here because it is always an increasing function. But in this case, there is increasing and decreasing together in an interval. If I have, I will say that condition as neither increasing nor decreasing. Can you give me an example? All constant functions are like that. Okay, so all constant functions, at some cases it will become positive, on some cases it will become negative, correct? So positive function means it will always be increasing and negative function means it will always be decreasing. Am I correct? For example, if I am going to say f of x is equals to 3. F of x is equals to 3 means y is equals to 3, correct? Y equal to 3, it will be like this, correct? So y is equals to 3, it is not increasing as well as not decreasing, so it always maintains 0, correct? So it means it is neither increasing nor decreasing. Okay, y equal to minus 2. Again, it is not increasing, not decreasing. It always maintains the same value. So I can say this type of function as what? Neither increasing nor decreasing. Can you understand what I am saying? All constant functions are neither increasing nor decreasing. It is not going up or it is not coming down. It maintains a flat value, correct? It means the slope is 0. It means your dy by dx 0. See, I am bringing differentiation now inside. It means your dy by dx is equals to 0. Can you understand? Yes. Okay. Now I am going to bring inside your differentiation here. How to use a differentiation in finding the increasing and decreasing of a function. Very simple. Please listen. There is a function f, Kana. There is a function f. I have to check whether this function is increasing or decreasing in a particular limit. For example, let me take sin x itself. It's a very good example. Let me take sin x. Okay. And I differentiate sin x. And I am differentiating sin x. What is differentiation of sin x? Cos x. Okay. I am taking an interval, open interval 0 to pi by 2. I am taking an open interval 0 to pi by 2. On seeing the graph, you will say 0 to pi by 2. It is what function? Increasing function, right? Okay. I am taking an interval 0 to pi by 2. Now what I am doing is, I am substituting any value in between this interval in f dash of x. For example, I will substitute pi by 6. So what is cos of pi by 6? Cos 30 degrees root 3 by 2. Am I correct? Is that value f dash of x positive or negative? It is positive. For any value, if I substitute inside, your f dash of x will become negative or no? Will it become 0? I cannot substitute pi by 2 because open interval I have set, correct? Even I cannot substitute 0. I can substitute only the values which is present in between. So all these all are first quadrant values, correct? If any first quadrant value, if it is substituted in f dash of x, it always gives greater than 0 for all x belongs to 0 to pi by 2. Am I correct? Any value I am going to substitute in f dash of x, it always gives positive value. If it is always giving a positive value, then I can say that f of x is increasing or strictly increasing function. F of x is what? Strictly increasing function. Okay, sir, then if it gives negative value, sir, strictly decreasing function. Can you understand what I am saying? Yes, so let me come one by one. F of x is sin x. I am finding f dash of x. In that interval, I am taking any one value. Since it is open interval, the last values I am not substituting. I am taking one value, substituting in f dash of x, getting a positive answer only. If I am going to get positive answer alone in that particular interval, I can say that the function is strictly increasing function. If I am going to get only negative value alone in that particular interval, I can say that the function is strictly decreasing function. Okay, sir, if the bracket is closed bracket like this, sir, what will happen, sir? I can even substitute pi by 2, correct? I can even substitute pi by 2. What is cos pi by 2? 0. So, I am getting positive values in this interval, correct? As well as 0, it means f dash of x is greater than or equal to 0. In that condition, I can say that the function is increasing function, not strictly increasing function. On that condition, I can say that the function is increasing function but not strictly increasing function. Okay, so I am going to write the conditions here. Please listen now. Very, very important. If there is a function f of x, okay, so I am going to find f dash of x. If f dash of x I am going to get greater than 0, it means the function is strictly increasing function in that interval. If f dash of x is greater than as well as equal to 0, at some case, I've told you, at some case your slope is becoming parallel to x-axis, slope will become 0. So greater than or equal to 0, it is said to be as increasing function. Similarly, f dash of x is only less than 0, it is said to be as strictly decreasing function. And f dash of x is less than or equal to 0, it is said to be as what function? Decreasing function. Can you understand? Yes. So, using differentiation, we are going to find what we are going to do, sir. A function will be given, intervals will be given. What you will do? You will differentiate a function, substitute the values from each interval to that function. Okay, and we will check whether the answer is positive or not. If the differentiation answer always gives a positive answer without 0, it means strictly increasing. With 0, it is giving a positive answer, it should be as increasing. Without 0, it is going to give negative answer, it means strictly decreasing. With 0, if it is giving a negative answer, it means only decreasing function. Can you understand the logic? Yes. Are you clear? Super. Friends, we are going to do this 3 sums, and here 2 sums are present. Altogether, I want you to make it up with 5 sums today, right? So all the sums are very basic and very important. Now listen carefully. Again I am saying, if you understand the logic, then this entire exercise is very simple. And similarly, the next exercise also looks the same, right? So once you understand concept, hereafter whatever chapter is there, you understand concept, the topic will look very easy. Okay? No need to have any teacher with you. Just to understand the concept, you can do any sum. In any book you can do any sum. Okay? Concept is very important. Listen carefully. Right? 6.2 exercise. Question number 1. Show that f of x is 3x plus 17 is an increasing on all real numbers. Okay. As I have said, a function is given. Question number 1. F of x is equals to 3x plus 17. Now I am differentiating that function. I will get what? 3. Yes. Now x belongs to real number, they have said. So any real number, for example, if I am going to substitute 0, then also it will going to be 3. If I am going to substitute any positive value, then also it will be 3. If I am going to substitute any negative value, then also it is going to be 3. Correct? So your f dash of x is always greater than 0. It means positive for all x. For all symbol is like this. For all x belongs to real number. Therefore I can say that f of x is increasing function. You can ask me, sir, when greater than 0, it is strictly increasing only. No, sir. You have said only increasing. In question, they have asked whether it is increasing or not. They are not asking whether it is strictly increasing. Even you can say strictly increasing, nothing wrong. But whatever they have mentioned in the question, to that you write the answer. If they are asking whether it is an increasing function, you say it is an increasing function. That's all. Prove that it is an increasing function means yes, I have proved it is an increasing function. Don't put some extra dialogues and all. Okay, they are saying whether it is going up. Yes, it is going up. It gives only positive answer. Then it is differentiated. Therefore, it is an increasing function. There is not much difference between strictly increasing and increasing. Okay, when it comes to differentiate strictly increasing and increasing, then you can mention which is strictly increasing, which is only increasing, right? Here they are asking whether the function is increasing. Yes, I proved that it is an increasing function. Okay, immediately some people brain will think like this. How la? Sir, constant it is got, sir. Constant if you have got, you said it is neither increasing nor decreasing. No, sir. Sir, very simple, sir. When f of x is equals to 3, sir, then f dash of x will become what? 0. Then I have said that it is neither increasing nor decreasing. Correct? Yes? See, when f dash of x becomes 0 for any function, then the condition is neither increasing nor decreasing. Keep it in mind, 1 mark question. Okay, now there is a linear function. I have got a positive value when I differentiated. How I can say it is neither increasing nor decreasing? It is wrong. Can you understand what I am saying? Yes? Yes, clear? Now, let me go with sum number 2, Kana. What is sum number 2 given? F of x is equals to e power x. Am I right? Now tell me what is f dash of x? Differentiation of e power x is also e power x. Now they have given x belongs to all real numbers. Okay. If I am going to substitute 0, what will happen? E power 0 is 1. If I am going to substitute positive value, what will happen? E power positive value will always give a positive value. If I am going to substitute negative value, what will happen? E power negative value will be 1 by e power positive value. So 1 by positive value, again it will give a positive value, correct? So I can say that as tan x, e power x is always an or ever increasing function. As tan x, e power x is also a ever increasing function. So what I can say is f dash of x is always greater than 0 for all x belongs to real number. Therefore, f of x is increasing function. They have said whether it is increasing or not. So just to mention it is an increasing function. Okay? Can you understand what I am saying? Yes. And similarly in examination, one time they have asked f of x is equals to log x. In the interval 0 to infinity, open bracket I have given, right? We have to check whether it is an increasing function or decreasing function. Okay? So one more question they asked this one. So I want you people to try out this question and tell me. F of x is equals to log x in the interval 0 to infinity, whether it is increasing function or decreasing function. I want you people to try out this one. Is very important. So definitely you have to work out, right? Now let me go with question number 3, Kanna. Question number 3 is very simple already. I have said f of x they have given as sin x. Correct? What is f dash of x? F dash of x is equals to cos x, differentiation of sin x. Now they have given interval separately and they are asking us to prove 0 to pi by 2. Just now I proved it, right? So what is f dash of any value you take in between pi by 4, I will take cos pi by 4. What is cos pi by 4? 1 by root 2, correct? So f dash of x is greater than 0 when x lies in the interval 0 to pi by 2, open interval. Therefore, f of x is increasing in the interval 0 to pi by 2. Can you understand? Now B, let me take, what is the interval? Pi by 2 to pi. Pi by 2 to pi means what value I can take? Shall I take 2 pi by 3, 120 degree? 90 to 180, 120 degree I am taking. So it will become cos 120. Cos 2 pi by 3 is minus 1 by 2. 100 times we practiced in inverse trigonometry, correct? So it means your f dash of x is less than 0. So for all x belongs to the interval pi by 2 to pi. In second quadrant cos theta is negative. So with that logic itself I can say, therefore f of x is decreasing in the interval pi by 2 to pi. Can you understand? Yes, very simple, Kana. Nothing difficult, very simple. When you understand the logic, it looks very simple. Okay, so taking a function, differentiating, substituting the interval. Positive means increasing, negative means decreasing. What is there in this one? I don't understand. People are still afraid of doing this type of sums. Okay, differentiating, substituting the value and checking whether it is positive or negative. Even a small kid can do it. Okay, so very simple question. Now, the real question comes after this only, Kana. Now, we have to find the intervals in the next two questions, and in that intervals we have to check which is increasing and which is decreasing. Okay, so this is the real part question, Kana. Real what I can say increasing decreasing question. Okay, now I need to find the interval, Kana. Find the intervals. What is the function given? F of x is equals to 2x square minus 3x, correct? F of x equal to what? 2x square minus 3x. Now please listen carefully. I am saying the procedure. First differentiate it. 4x minus 3. Equate it to 0. Okay, equate f dash of x equal to 0. So 4x minus 3 equal to 0. X is equals to 3 by 4. Okay, x is equals to 3 by 4. This number is called as critical number. This number is called as what number? Critical number. So once what happened is, a fellow, when I am saying in words, okay, first generally what I will do is in offline classes I used to say the procedure. Okay, so once I am saying that procedure, I have said this as critical number. One of my student wrote kritika number. Okay, it is not kritika number, it is critical number. Okay, critical number, because at that point the function might be changing. That is why we say it as critical. Critical care unit means what? ICU we say, inside a person goes, we don't know, whatever anything might happen, correct? So critical means at that point the function might be changing. That is why we say it as critical number. Now what we have to do, sir? Plot the interval from minus infinity to plus infinity, because they have not given any interval. What critical number I have got? 3 by 4. correct? So now I have made it up into two intervals, that is one interval from minus infinity to 3 by 4, another interval is from 3 by 4 to infinity. This is one interval, another interval is what? 3 by 4 to infinity. Now take one value from this. Can I take 0? Anyway it is positive, I can take 0. So I am taking x equal to 0. Substitute x is equals to 0 in f dash of x. Always you have to substitute in f dash of x kanna. So 4 into 0 minus 3, you will get minus 3. Positive or negative? F dash of x is less than 0. Correct? So in the interval what? Minus infinity to 3 by 4. Therefore f of x is decreasing in the interval minus infinity to 3 by 4. Can you understand? Super. Now take one value from this kanna. Greater than 3 by 4. 1 is greater than 3 by 4. Correct? Any value, even 100 you can take. 200 you can take. Your wish, right? I am taking a simple value. So f dash of 1 is equals to 4 into 1 minus 3. 4 minus 3 is 1. Is it positive or negative? Positive. F dash of x greater than 0. I can say that f of x is increasing function in the interval 3 by 4 to infinity. Can you understand? In the interval what? 3 by 4 to infinity. Okay, sir. Now what is the procedure? Let me give you the procedure for this one. It looks very simple. Okay, whenever you have to find the intervals of increasing and decreasing function. Okay, finding intervals of increasing and decreasing function. Finding intervals of increasing and decreasing function. Okay, so what you have to do is a function will be given. A function should be differentiated. Equate the differentiated function to 0. You will get x value. That value is called as critical number. Okay, plot the intervals. Plot the intervals in number line like this. Correct? From minus infinity to plus infinity, critical number. For example, sometimes you might get two critical numbers. So two values you have to plot. Altogether you will get three intervals, right? So plot the intervals. Then substitute one value from each interval. Substitute one value from each interval in f dash of x. If f dash of x is greater than 0, it is said to be as increasing function in that interval. If f dash of x is less than 0, it is said to be as decreasing function in that interval. That's all. F of x is given. F dash of x you have to do. Equate f dash of x to 0. Get the critical number. Plot the intervals. Substitute one value from each interval. If take f dash of x greater than 0, if it is greater than 0, it is increasing. If it is less than 0, it is decreasing. Can you understand? So I want you people to note it down. Okay. So note down this one. This is very, very important. Let me go with sum number 5. You can understand better. Okay. I think you will get two critical numbers there. Right. So what is the function? F of x is equals to 2x cube minus 3x squared minus 36x plus 7. If I differentiate, what will happen? It will become 2 into 3 is 6x squared minus 6x minus 36. Am I correct? Shall I take 6 common out? So it will become what? X square minus x minus 6. Correct? Now if I am equating f dash of x to 0, see, first step I have differentiated, second step I am equating it to 0. So what will happen? 6 into x square minus x minus 6 is equals to 0. Taking 6 to the other side, x square minus x minus 6 equal to 0. X square minus 3x plus 2x minus 6 equal to 0. Taking x common out, x minus 3 plus 2 common out, x minus 3 equal to 0. So x minus 3 into x plus 2 equal to 0. So x is equals to 3 and minus 2. So these two numbers are called as what numbers? Critical numbers, correct? No need to write it in an exam. Okay, but it is a critical number, you should know. Now what we have to do after getting critical number? We have to plot the interval. So they have not given any interval in the question. So from minus infinity to plus infinity, the value is minus 2 and 3. The value is what? Minus 2 and 3. Okay, so what we have to do? We have to split the intervals. Minus infinity to minus 2, one interval. Minus 2 to 3 is another interval. 3 to infinity is third interval. Now take one value, substitute x equal to minus 3. Where you will substitute? In f dash of x. Okay, substitute minus 3 in f dash of x. Check what answer you are getting. Positive means increasing, negative means decreasing. Take one value, x equal to 0, substitute in this interval, check what you are getting. Okay, positive means increasing, negative means what? Decreasing. And again take one value, substitute in this f dash of x, check what you are getting. Positive means increasing, negative means decreasing. Can you understand the logic? Yes, very simple. So I think this is question number 5. Question number 6 contains many sums based on this one. Kana. If it is trigonometric terms, you leave it. I'll teach you, right? So other than trigonometry, you can do all other sums in question number 5. Okay, so it is very simple. I want you people to try it out. Whichever question in that exercise you can do based on this logic, please try to do it. Okay, then only you can get what is that. Okay, what is increasing decreasing function, how we are solving, everything you can get. Can you understand the logic? Yes, are you clear with the basic concept? Very simple. Function is there, differentiated. From an interval, a value is substituted in the function. It gives positive answer, it is increasing. It gives negative answer if it is decreasing. Can you understand? Yes. So with this, I'll wind up this session and we'll meet you in next session. Thank you.